in this lecture, then we're going to continue looking at this meal grid, but improve the way we download all those logos and do it in an asynchronous way using a background thread. Go into the Restaurant Collection View controller, and you'll see what we have here. Most of our work is going to happen in here. It's actually going to happen all in one function, largely. Function that we want to change is this collection view cell for item at index path. Previously, we just downloaded every logo as it was needed, or as long as we had a logo string for that. So remember the really bad line we had before? It's this line, the contents of URL, where we're downloading the image and we're doing it on the main thread. So we need to do this line on the background thread. And as you watched in the videos, I hope you saw the special code that allows us to do that. It's the dispatch async method. So this is what I'd like us to do. For one, I'm going to take out this if index path equals section, because I'm just going to repeat all this for every section so we have a lot more things downloading. It'll make it more interesting. I'm going to take this out. Also, tidbit here that I looked up today. I want to untab those things, and in Xcode it's command and left brace to move that back. So all that, we're going to do that for every section now. All right, so where we want to focus our efforts is in here. For one, we don't need to start a background thread unless there actually is a logo URL string, right? So I'm going to put this in here. Oh, warning, there's going to be a lot of curly braces today and a lot of if-lets. I'm sorry. You can handle it, good. So I'm going to create a constant called the dispatch queue priority default. Sorry, hang on. I'm going to let this constant priority equal this special constant, dispatch queue priority default. Then I'm going to do the dispatch async this method, so that I'm going to tell it what queue to run on and what to do on the background thread. So this queue is going to be, I'm going to have to use this syntax. I'm going to say dispatch underscore get underscore global underscore queue, and I'm going to give it a I'm going to give it the priority that we just had, and the flags are going to be 0. I'm tabbing through here because it's way easier, and then press enter. And when you do this, it will auto expand this closure to show you what you're doing here. So this is we're writing a closure that will return nothing. So all of our background thread code needs to go in this area, this block. I think there's an alternate syntax where you have the trailing closure. You remember that? Where you just have the curly braces at the end of this statement without this. So if you like that, you can, in fact, say, this is equivalent code. I'm going to close this, and then I'm going to get rid of that one, get rid of this, and the code that's here is the code that will run in as the closure on the background thread. It's a little bit cleaner syntax maybe, but maybe it's less readable. Either one is fine. Paul would do it this way though, wouldn't he? I think he would do it this way because it's less writing, it's less code. Okay, what do we need to do? We generally want to do what's down here, right? Right. So I'm going to cut that. This one goes to that, yeah. So I'm going to get these, cut, paste. So on the background thread, I'm going to create the logo URL. I'm going to do my super slow line, which is getting the contents of the URL. And then I'm going to create an image from the data that was downloaded. The last thing I do here is set the image property of the logo image view on the cell to the thing that I downloaded. And I think really if I were going to be safer here, I need to say, this should probably be if let here. Because it's possible that could fail, I think. What I'm doing here is updating the image property on the view, and that is a UI thing, which means it has to happen on the main thread. It can't be done on the background thread. If we do this now, it won't work. So in order to do this, we have to really repeat what we did up here, which is get a new thread, but make sure we get the main thread instead of this background thread. And this is the code to do that. So for this particular line, I'm going to say dispatch async, and then I can say dispatch underscore get underscore main queue. So this method will get like a reference to the main queue. And then what I want to do here is execute another closure, which is this. So from the main thread, I need to execute this line of code. So I'm going to update the UI from the main thread. Does that make sense? So after I've done the work of downloading the image here, then I would have to get on the main thread and run some code from it. I don't know if y'all have done much multi-threaded programming before, but this is a really pretty nice API for it. Did you do any operating systems? Okay. So let's see if this works. Another improvement that this gives us is that before we did all these, we were blocking, so we ended up doing them sequentially. We did the first one and it was done. We started the second one. And this one, they should all be able to start asynchronously. So they'll be overlapping in their time, so they should load faster. But let's just make sure it works. Maybe I've done something wrong. You see that? Pretty cool. In order to make this really clear what's happening, I'm going to do something bad to exaggerate what's going on. What I'm going to do is I'm going to make it take 2 seconds to download every single image. And to do that, I'm going to, right before I download it, I'm going to cause the system to sleep for 2 seconds with the sleep command. But since I'm doing this in the background and in parallel, it's only going to be about 2 seconds altogether because they're all kind of downloading at the same time. To show you how nice it is, I'll in just a second, I'll remove the background stuff and we'll just do it sequentially and compare. So notice how fast this is, okay? For all of the images to come in and load. 3-4 seconds? We could make this even worse. Let's make there be more than one section. You want to have 5 sections? This might make it a little bit worse. It's actually only going to load the stuff that's visible, but it's going to download Taco Bell twice, I think. It's really, it's slow. I don't know if you can't tell it, but it's sluggish from here. Because every time it comes back, it's downloading them again. Ugh, you see it's super slow, it's bad. Okay, so let me show you how bad it is though if we don't do it asynchronously. So I'm going to comment out that line, and whichever line matches it, which is probably this one. So now that's just saying I didn't ever use that, but does that work? Yes. So now, because I commented out those 2 lines, now I guess I should get rid of this one too. This is basically equivalent to what we had last time, where we're doing it sequentially. So let's see what it's like in this case. You see it's not showing anything until it finishes all of downloading all the cells. And they each take 2 seconds. And there's what, like 7 or 8 of them? Ugh. Is it killing you? It's killing me. You sure there's not something else wrong?
Okay, wow. Showing.
No, I just tried to scroll and it's horrible. It's horrible because it's trying to, it has to do all that on the main thread, which is updating the scrolling. Oh. This is how you make a terrible app. I don't know if you can see how this isn't super slow because it's doing all of that loading and updating on the main thread. All that downloading is happening on the main thread. That's not what we want to do. This is exaggerated a lot because I added in those 2 seconds. But if it were like a really big file, which, it's unpredictable how long it's going to take, network conditions unpredictable, it's not an unrealistic amount of time that it might take to download. Yeah? So whenever you're doing anything that could be time consuming, like more than a few hundred milliseconds, you should probably do it on a background thread. Well, we may find better rules of thumb than that online. That's just off the top of my head. Okay, so I'm going to bring back all of my asynchronous stuff. So does this make sense? It's a little funky because you've got these 2 calls that look sort of similar, these 2 dispatch asyncs, one's nested in the other. So this is the outside one, we're getting a background thread, doing our long-running work, and then inside of it, once the work is done, we get a reference to the main thread and update the UI like we need to. Yeah? All right, let's make another improvement to this. Did you notice I have several sections and they do end up reusing all the logos again. There's no point in downloading those again. Right, even in the background, because we already downloaded them once. What if we had a cache where we saved all the images that were downloaded? If we just had a few of them, then they would fit in memory and it would give us a lot better performance. So let's see how we could add in a cache. To do this, I'm going to create a dictionary to implement the cache. This is a super basic cache, but I think it shows you, and it's also in memory. It's not going to save them to the disk permanently. It's just in memory. I'm going to create a variable that is our image cache, and it's going to be a dictionary that goes from strings to UI images. Oh, and I need to create one of those. Whenever I download an image, I'm going to save it in this dictionary, and the key I'm going to use is its URL, because that's a unique identifier. Before I show any image. I'm going to check to see if it's in the cache first. If it is in the cache, I'll just use the cache version. If it's not in the cache, then I'll actually do the downloading. Okay. So once again, I still don't want to do any of this work unless there actually is a URL string. Yeah? So inside here, I'm going to say if, no parenthesis, if let image equals image cache at logo URL string. So if there's something in the dictionary for this key, which is the logo URL string, then I want to use it, right? In that case, I can just say cell.logoImageView.image equals image. I've already extracted it from the cache here in my if let.
Otherwise, you do the next one.
Otherwise, if it's not in the cache, then I'm going to do all of this. Oops, wrong way. There we go. With one addition, and that is, once I actually have it downloaded, which would be here, I need to add it to the cache. So I'll say image cache at logo URL string is equal to logo image. Isn't that what it's called? Yes. Now this is going to give me an error. Why is this error happening? Because this is in a closure, and image cache is a property of this object. So I have to say self to get to it. And to make it very clear what's going on, I'm going to add some print statements here. So this is going to say getting image from cache. And down here, let's see, where is it? I'm going to print downloading image from web. That makes sense? Just so we can see the different times when that's happening based on the user interaction. Does this make sense? So we're saving all these images in memory to this dictionary, and we always check the dictionary first to see if we've already downloaded it. And if we have, then we just use it. And so this should further enhance performance because now we should only have to download the images once, and anytime they're reused, we get them out of memory, and that'll be super fast. Let's run it and see if it works. So I'll rerun this so you can see all the stuff that's happening. So those are the first time they're downloaded from the web. And notice as I scroll down and they're being reused, when it lays out the additional sections, it gets it from the cache. I don't know if you can tell. You can tell because this bar is getting smaller. Just scrolling down will hit that again because every time it relays out a cell, even though it's already laid it out, but if it went off the screen, then it's been deallocated and it's going to have to, every time you get to view the cells, it's going to call cell for row and index path, cell for item and index path. So we get a lot of benefit because of the way iOS works to saving these in an image cache. I don't know if you can tell, this feels pretty much completely normal now because they're all coming from the cache, even with that 2-second delay, which was a little exaggerated perhaps, because we only felt it the first time, and after that it's all gone. So this is nice. There are a lot more advanced ways of caching, like for example, if you saved these to disk, then they would still be around the next time you ran the app. Ours are going to go away every time you close the app and reopen it. So if you knew that you had files that it made sense to keep that long, you might want to do that. Now, our cache is never invalidated, so if that file changed on the server while we were running our app, we would never go out to the server and get the new version of it. So when you're caching things, you do kind of have to know how long is the kind of the lifespan of this item that I'm caching, because if it's short, then you need to make sure your cache is even shorter. Your cache, the lifespan of your thing in the cache is even shorter. So we've seen how we could make a really simple image cache using a dictionary. We've also seen how to use dispatch async. We've also seen how to use a lot of curly braces. Isn't that beautiful?